Hey class, this is Mr. Roberts at Shasta High School. We're going to be going over the Chapter 1 test, and we'll discuss what's going to happen with those test scores in class. The first question has appeared on all three of our chapter tests so far this year. It says simplify your answers, and your answers may not contain negative exponents or giant ones, common factors. So you basically have to get everything together that can be and no negative exponents. And if you look at it, all four of these are monomials. That means that there's no combination of different terms. They're all single term expressions that we just want to get in the most simplest form possible. The first one involves raising something to the second power. And of course, there is a rule for this, and I've got all of these off to the right. If you want to look at them in our notebook, you can review those laws of exponents. I'm just going to use the definition of what an exponent is, because this is a fairly simple example. So when I see that something is raised to the second power, and again, what's the something? The something is everything inside of these parentheses, right? So I have 3a squared b to the eighth being raised to the second power. That means I have two identical copies of all of those factors inside of the parentheses, right? That thing in the parentheses multiplied again by another copy of those. So I could rewrite this as 3a squared b to the eighth, and then times another set of them, 3a squared b to the eighth. And you'll notice this is just a multiplication problem, and I definitely can commute the terms. I see that there is a 3 times a 3. 3 times 3 is 9, or you could write it as 3 squared, but I'm just going to go ahead and write it as 9. I think that's the most simplest form because there's not an operation needed to evaluate it. So we'll just write it as 9. The next thing that I see is I've got a to the second power times another a to the second power. Remember, a to the second power means it's two factors of a, so I've got 1, 2, right? 1, 2, and then 3, 4 factors of a. So this is a raised to the fourth power. And then the last thing I have are 8 factors of b times another 8 factors of b. So I don't even want to try and say it. There's too many of those factors of b. But b to the eighth times b to the eighth would give me exactly b raised to the 16th power. There are indeed 16 factors of b there. And this is the answer for the first part, part A. Let's move over and look at B, which disappeared, but now it's back. You know, always it's nice to kind of just think about a simple thing that you can do. Like, what's one thing I could do looking at this? Well, one of the things I noticed right away is that I do have the number 10 in the numerator and 2 in the denominator. 10 divided by 2 is 5. And I can also show that by just writing, 10 is 2 times 5. And I've got a to the fifth over 2 times a to the negative third. So I can very clearly see that there's a giant 1 there, right? 2 over 2. So I can write this as just simply 5 times a to the fifth over a to the negative third power. The mechanism we've had for looking at how to deal with negative exponents, regardless of where they're at, is to just kind of neutralize them. So I know that if I multiply a to the negative third times a to the positive third, that would give me a to the 0 power in my denominator. And that a to the 0 power, right, a raised to the 0 power, is equal to the number 1. So this just becomes a 1 in my denominator. Now I can't just decide to arbitrarily multiply just the denominator by a to the third, but I can definitely multiply by the number 1, right? Multiplicative identity says you can multiply anything by the number 1 and you don't change it. And if I multiply by a to the third over a to the third, right, I'm not changing this quantity, I'm just changing its form. Well, when I do that, I can see that I have a 5 in the numerator, and I have exactly 8 factors of a. So this is 5 times a to the 8th power. And I probably would write my answer without over 1, right? 5a to the 8th power, just like that. All right, so that's A, B. Now let's take a look at part C. C, there's a lot of things we could do with this. I think the thing that catches my eye is I am multiplying an a squared times an a to the negative second. So right off the bat, these two make a to the 0 power, which equals the number 1. So effectively, this a squared times a to the negative second is just equal to 1. So I don't need to concern myself with that. However, I do need to concern myself with the fact that there's 4, which is 2 times 2, times another 2. So this does have the number 8 in it. And the other thing I need to concern myself with is there's 3 factors of x, right? 8 times x times x times x, or 8 times x raised to the third power. So that is A, B, and then C. Finally, let's look at D. D has, it does have a negative exponent, and I'm going to deal with that the same way I did in the previous problem. But I think I want to start with looking at the numerator. So the numerator is 3x raised to the second power. Now, because these are both factors, right, it's 3 times x, I can raise both the 3 and the x to the second power, right? That's one of our laws of exponents. Or I could just choose to write out, I've got a 3x times another 3x, right? So in my numerator, I've got 3 times x times x. In my denominator, I have this 27, which is 3 times 9, and 9 is 3 times 3, so I might write it all the way out, right? There's a 3 times a 3 times a 3. I also have this x raised to the negative third power, and I'm going to neutralize that just like we did in the previous problem by multiplying. I'm sorry, I called it a to the negative third, it's an x. I'm going to multiply by x to the positive third, and when I do that in my denominator, I'll also follow that up with an x to the positive third in the numerator. So now if I look at it, I have a couple giant ones. I have 3 times 3, or 3 over 3. Or essentially, I've got a 9 over 9, right? But I've broken it up into 2. So that forms a 1. In my numerator, I have, you can see 1, 2, and then 1, 2, 3 factors of x. So I have a total of x to the 5th power. And then in the denominator, you can see these, x to the negative third times x to the third is x to the 0, which is the number 1. So I'm left with just x to the 5th all over 3. And that is the answer to part D. Now, one of the things that I'm going to be including is, of course, these videos. And you can see I've got the laws of exponents here. But in addition to this, I'm going to have a listing of extra practice problems that you can try. So remember, when you are in OneNote, you can generate your own practice and look at it, but I will be putting problems and the answers right next to it. Never be satisfied with an answer, right, until you're sure that you could get that consistently, independently, and reliably on your own. All right, that's it for this problem.